Okay, so let's have a little bit of a clarification here. Some of you are having trouble with the whole idea of the Roman numerals and when you use them and how you use them when we write ionic compounds. So this can be a short, hopefully less than about 5-minute presentation to help you out with this. Well, first of all, let's look at the periodic table. The Roman numerals tell you how many electrons, or basically what the charge of an atom is going to be when it gives or takes its electrons. Now, we know that this column here is going to be a +1. This column is going to be a +2. This column always wants to give 1 electron. This column always wants to give 2. We know that this column here always wants to give 3. These Roman numerals come in to these elements here in the middle, the D block. Because here's what's happening with the D block. The D block elements don't always give or take the same number of electrons. They can vary their oxidation numbers. They can vary the amount of electrons they give or take. So they can vary their charge, which varies how many of them there are in an ionic compound. For example, iron here. Iron can be either a +3 or a +4 for its oxidation number. It can either be a +3 charge or a +4, depending upon does it give 3 electrons or 4 electrons. And it changes depending upon a lot of other factors, which you don't need to worry about. You just have to realize that all of these guys here in the middle, and to a lesser extent, some of the ones over here like tin and lead, they can give more than one number of valence electrons. So we have to have a way to say how many is that element giving. So we just said iron. Iron can be a +3 or iron can be a +2. Well, if we put that with chlorine, chlorine over here is always a -1. Chlorine always wants to take 1 electron. So when we drop and cross these, we get iron 1. I don't need to write a 1, I get FeCl3. But if I have an iron that is a +2, I get this. Now, how do we say the names of these things? This is where the Roman numeral comes into play. If you have the formula, oh, that's FeCl3. I see it. That's the iron that gave 3. Oh, I see. This is FeCl2. That's the iron that had a 2 charge. But if we're saying the names, both of these are iron chloride, aren't they? Because they're both iron and chlorine. Well, if all I say is the name and you don't have the formula, if I just said iron chloride, you wouldn't know which one I'm talking about. Is it the iron that gave 2 or the iron that gave 3? That's where the Roman numerals come into play. You have to have a Roman numeral to tell you what did that particular iron do. Well, up here, this iron was a +3, and when we dropped it, you see that's a 3 and a 1. So this is iron 3 chloride. This iron here was a +2, so it's iron 2 chloride. This Roman numeral tells me what this iron is doing. This is the iron that had a +2 charge or a +2 oxidation number. This is the iron that had a +3 oxidation number. We don't need to do this. That is wrong. You would never ever say iron 3 chloride 1 because chlorine is always a 1. It doesn't change. It doesn't vary. So therefore, you don't ever need a Roman numeral with chlorine. What elements need these Roman numerals? For the most part, they're ones here in the middle of the periodic table. Now, they're D block. These guys don't need Roman numerals. They always give 1 or 2. I don't need to say sodium 1 chloride because sodium is always a 1. It doesn't vary. It doesn't change. With iron, I've got to have a way to say, is it the iron that's 3 or the iron that's 4? The same thing with copper. Copper can be a +1 or a +2. Well, you've got to say in the name of the compound, is it the copper 1 chloride or is it the copper that's 2 chloride? And that makes a difference. Because now, let's look at some examples just real quick. If I said copper 1 sulfide versus copper 2 sulfide, let's see what difference this makes. So I know it's copper. I'm telling you right there, it's a +1. Sulfide, that's sulfur. So this is the copper, that's a +2. That's sulfur. Sulfur is right here. Sulfur is always a -2 because of where it is in the periodic table. So now we drop and cross these and we get Cu, copper, with a subscript of 2, sulfide. Here it's just copper 1 and 1 because the 2's cancel out. We drop, cross, and reduce. So you see the difference here. This number here doesn't tell you how many coppers there are. It tells you what copper was doing. And that tells you what you drop, cross, and reduce. This was the copper that was a +1. This is the copper that's a +2. Notice sulfur, we don't have to say 2 for sulfur because sulfur is always a 2. We only use these Roman numerals for the elements that have more than one choice for their oxidation number or what charge they're going to have when they give and take electrons. Now, you already know none of these guys here, no Roman numerals. You know none of these negative guys over here, no Roman numerals. It's going to be just these ones here in the middle. How do you know what they are? Well, you're not going to memorize them all. Some of them, like manganese has it can be like a +2, a +3, a +5, and a +7. So you have to use a Roman numeral to say what its oxidation number is. You're not going to have to memorize all the possible choices. That's the point of using the Roman numerals. So let's do, if I said nickel 3 bromide. Nickel's one of those ones, it's in the middle. So it can vary. We can't just look at it and see what its number is. So here I write it. This is nickel with a +3. Bromine. Bromine's over in this column. That's always a -1. Now I drop and cross this. That's nickel 3 bromide. Remember, the Roman numeral tells you about what nickel is doing, not about how many nickels there are. This is the nickel that's going to give 3. So it's a +3. Drop across, NiBr 3. All right, so I hope this helps clear up the confusion with the variable oxidation numbers, or when you use these Roman numerals and when you don't. Go back through the answers to those problems that you attempted, and please ask in class if you have any questions about why this one is this particular Roman numeral or why this one doesn't need a Roman numeral.